Hello, everyone. Please turn to page 23 of your notes. Page 23 has two parts. The top half is a reminder on when you're given an equation of a sinusoid and you need to graph the equation. But today you're going to be given a graph and you're going to have to write an equation. So if you look at the bottom half of page 23, this is what you're going to want to reference when you get stuck on certain parts. The hardest part is part 4. Part 4 talks about how to find B. B has 3 steps to it. The first thing you want to do is find the distance between critical points, and I'll go through all that. Then you want to find the period, and then you're going to want to find B. So look at number 4 on this page 23 when you're having a hard time finding that B value. So go ahead and turn the next page, and we're going to go through writing an equation of this first example. So this first example is in degrees. Degrees are easier, so that's why we're starting with degrees. The very first thing you're going to want to do is draw in the sinusoidal axis. Try to do it as realistic as possible. Notice we're given the max and the min. Max is 10, the minimum is 2. So you're going to want to draw your sinusoidal axis halfway between those. I usually like using a red dotted line. So go ahead and draw that in. And now we're going to figure out what the C value is, the sinusoidal axis. It's the average of the maximum and the minimum. So C is equal to 10 plus 2 divided by 2. So the average of 10 and 2. The average by doing 10 plus 2 divided by 2, and you'll get 6. So C is 6. Next thing you're going to want to do is find A. Now, A is 4. The reason it's 4 is because it's the difference of the max and the SA of 6. So 10 minus 6 is 4. It's also the difference of the SA and the minimum. So 6 minus 2 is 4. The next thing we're going to want to do is find B. Now, B has many steps. The first thing to find B is you're going to want to draw in all the critical points between negative 60 and 180. So whatever values you're given on the x-axis, find all the critical points, draw them in between those two. So we have this minimum at negative 60. I'm going to draw that in with blue. Then we have this SA. Then we have this max, another SA, a minimum, an SA, and a max. And then you're going to want to put corresponding slashes on the x-axis for each of those critical values. And now we can start figuring out the distance between critical points. So what you want to do is take 180 degrees and subtract negative 60 degrees. So the distance between critical points is going to be equal to 180 degrees minus negative 60 degrees. And then we're going to have to divide that difference by the number of intervals between all your critical points. There are 1, 2, 3, 4, 5, 6, 7 critical points. So there are actually 6 spaces in between them. So we have 1, 2, 3, 4, 5, 6 spaces. So again, you're going to count the spaces, not the points. And again, that since there's 7 critical points, there's going to be 6 spaces. It's always 1 less than the number of points. So we're going to divide that by 6. So we have now 180 minus negative 60 is 240 degrees. We're going to end up adding, and we're going to divide that by 6. So our distance between critical points is 40 degrees. And you can also check that on your graph. So notice we're given negative 60. If you add 40, you get negative 20. Add 40 again, you get positive 20. You get 60, 100, 140, and 180. What's nice about doing this is then you can check that you're correct, because if it works, you know you did it correct. So then you can find the period. The period is equal to the distance between critical points times 4. So we're going to do 40 degrees times 4. Again, this is all on page 23. So the period is 160 degrees. You can also check this on your graph, because if you look at your graph, you can see that we have this maximum at 20 degrees. The next maximum is at 180 degrees. So that's one period. And look, the difference between 20 and 180 is 160. So that means we've calculated that correctly. So now you're ready to find B. B is equal to, in degrees, 360 degrees divided by the period, which is 160. So then you reduce that, and you're going to end up getting 9/4 because 36 divided by 4 is 9, 16 divided by 4 is 4. So B is 9/4. So now that we have A, B, and C, we're ready to start writing the equations. You actually never fill out D because D changes depending if it's sine or cosine. And for sine, you can use essays going up. If it's an essay going up, it's a positive sign. You can also use essays going down. If it's an essay going down, it's a negative sign. For cosine, positive cosines use maximum values. For negative cosines, use minimum values. There's actually an infinite number of correct answers you could write. So what I like to do is just set up both of the equations, one for sine and one for cosine, using A, B, and C. So what I'm going to do is write y equals for both of them. And I'm going to use this form up here where C comes first. So we're going to write y equals 6 on both of them because the C value is the same for both. I'm going to leave the plus sign blank because it could be plus or minus. Then comes the amplitude A, the 4 value, and then one's sine and one's cosine. Right after the trig function comes the B value we just found of 9/4. So go ahead and write that down. And then it's going to be an open parentheses after 9/4. And because it's degrees, you're going to write theta. Now what we're going to do is look at the graph and we're going to think, okay, for sine, we're looking for SA values. So the first one I'm going to look at is this -20. So -20 is right over here, and -20 is an SA value going up. Because it's an SA value going up, when I write my equation, it's going to be a positive sign. And the reason we write plus 20 degrees is because you're subtracting a -20, and so it ends up being positive 20. Now, that's not the only correct answer. There's actually an infinite number of SA values you could use for sine. I'm going to go ahead and erase this one and write one more possibility. You could also use this 60 degrees. This is an SA going down. So when we write this, it's going to be a negative sign. And the reason we write -60 is because it's minus a positive 60. So now we're going to start writing it for cosine. Cosine, you want to look for a maximum or a minimum. I'm first of all going to look at this maximum of 180 degrees. Because it's a maximum, it's going to be a positive cosine. And because 180 degrees is a positive number, you're going to write minus 180 degrees. So that is one possibility using a maximum. Again, it's a positive cosine because you used a maximum. Now, we could also use this minimum of 100, this maximum of 20, or this minimum of -60. I'm going to go ahead and show using the minimum of -60. We're going to write plus 60 degrees because it's a negative number. You subtract -60, so it ends up being plus 60. And because it's a minimum, it's going to be a negative cosine. Again, there are many different answers, but those are two we're leaving on here that you could use. On to the second problem. This one's radians, so it's a little bit more difficult. And but the main difference is that B is now going to be 2 pi divided by the period instead of 3/6. That's the main difference. So this time we're given a maximum at 11 and the SA at -13. You're not given the minimum, which is okay because you really don't need the minimum. And so now that you've drawn the SA, I'm going to go ahead and draw in all of our critical points between, sorry, that was my puppy. So anyways, I'm going to draw in the critical points from positive pi/2 to 7 pi/6. Pi/2 is a minimum, and then we have an SA and a max. So I'm going to go ahead and start finding our letters. I forgot to write down that C is -13 and A is going to be 24 because it's the maximum of 11 minus -13. But let's now move on to our B value. To figure out B, remember you first want to do your distance between critical points. And to do the distance between critical points, you take the two values given on your x-axis. They were 7 pi/6 and pi/2. We're going to subtract those two. And then we're going to count the spaces in between. There's 3 critical points, so there's 2 spaces. So we're going to take the 7 pi over 6 minus pi/2 and divide that by 2. And then I'm going to rewrite it with common denominator. So it ends up being 7 pi over 6 minus 3 pi over 6. So we have 4 pi over 6 divided by 2, which reduces to 2 pi over 3 times 1/2. Because if you're dividing by 2, it's the same thing as multiplying by a half. So now we've simplified this to have our distance between critical points be pi over 3. From there, we can now find our period. The period is pi over 3 times 4. It's always the distance between critical points times 4. So your period is 4 pi over 3. Now that you found the period, we can find b. Because this is radians, b is going to be equal to 2 pi divided by the period. So 2 pi divided by 4 pi over 3 is the same thing as 2 pi times 3 over 4 pi, the reciprocal. The pi's cancel, and then that simplifies to 6 over 4, so b is 3/2. Now that we have a, b, and c, we're ready to start writing the equation. So set it up just like we did before. Y equals the c value of -13. Leave a space for the positive or negative sign. Then you write the a value of 24. One is sine, one is cosine. Then you write the b value of 3/2. Because this one's radians, you're going to do, after your parentheses, you're going to do an x value. So now you want to look for values to use for your d value. Remember, there's an infinite number of d values. This time we were given a minimum of pi over 2 and a maximum of 7 pi over 6. So we were not given an SA. So in order to find that SA, you're going to use your DBCP, which we found to be pi over 3. And you're going to use that pi over 3 to help you find the value in between, the SA value in between pi over 2 and 7 pi over 6. So what you want to do is take pi over 2 and add pi over 3, which is your DBCP. So pi over 2 plus pi over 6 need to have a common denominator. It's 6. So that ends up being 3 pi over 6 plus 2 pi over 6. So we have 5 pi over 6. So that's your SA value. I would just use that one. It's an SA value going up, so it's going to be a positive sign function. And you write minus 5 pi over 6 because it's a positive number. It's always subtracting. Now for cosine, you can use either the minimum or the maximum. I'm going to go ahead and use the maximum of 7 pi over 6 because it's a maximum, it's plus. So here's your assignment. It's due Monday after Thanksgiving. All the answers are online on Canvas. Good luck. And you can always go through the video again. It's on Canvas also if you need to see the explanations again. Have a great Thanksgiving.